Hello everyone, in this very brief video I'm going to show you how you can use the Bochs emulator with IDA to decrypt some malwares and then have a proper IDA database that we can use to, well, analyze what it does. This is a curious malware that I found in some blog post talking about some group. I don't do attribution, but it seems that this malware came from some people. So let's open this malware and take a look to it. Okay. It is doing the initial auto analysis, and here we are. It is here. So this is the DLL main, and then it will do some stuff. Then we have some keywords over here. These are some algorithms for doing string decryption, and we really don't know what they do. And finally, they execute these functions. What do they do? There's a global pointer functions. This is what we are going to discover. We are not going to do a full malware analysis to determine how it works, where it connects, or what it downloads, or what. No, we are not going to do that full analysis. We are just going to use some features of the Bochs emulator to decrypt it and have something that we can read. Okay, so if we take a look to these keywords, we can press the key X to see the X-rays, and we will see that value, global value, is being written in this function, sub 18, whatever. If we go there, we will find that it is calling some functions to decrypt some strings. We can either guess the functions, don't do that, or simply run this code and decrypt. Running malicious code is always, dangerous. So it is better to either not run it or run it with an emulator, which is actually what we are going to do. In this function, if we go to the top, we will see that it is loading functions from kernel 32. So I'm going to call this function by going to the top and then pressing N, resolve kernel 32 functions. Okay, now if I press X for seeing the code reference, we will see that it is being called from DLL main and also from service main. I think that this function is actually the one that we are more interested more than the DLL main. If we take a look at the second function, after resolve kernel 32 functions, we will see actually the same. Some rare strings that are naturally encrypted, and it calls some function for decryption. We have two ways here. As I said, we can do it in either a statically way. We take the decryption algorithm here, and then we call, for example, IDA Python, or simply, and it's much better because we don't lose time on the stuff that the malware authors want us to stay more time instead of determining what it does. So what we are going to do, let me go back, is execute these parts, these all functions. Okay, this was ASBAPI 32, sorry. So we need to execute the service main function. I'm going to put here a breakpoint. It's not required, but it's for me as having some kinds of marker. And now I'm going to choose the local Bochs x64 debugger. So I'm not going into details about how to set up the Bochs debugger to be working with IDA. There is a very nice document from the hex-rays people documenting it. I will put the link in the description of the video. The Bochs emulator IDA's debugger was written back in the day, long ago, by a friend of mine, Elias Bakalani. And well, it's actually a very nice toy, tool that I use a lot for doing this kind of stuff, decrypting some specific malware parts. Okay, so let's run. As I said, I'm not going into details about how to use this module because it is already very well explained. And well, what we are going to do is simply run it. Press F9 and it will start running it, and well, after a while it simply stays there saying running, and the only option that we have is suspend. Well, so far so good. It stops at some place, we don't really care. If we press Ctrl E to see the entry points, we will see that here we have the service main, which is the one that we really want. And if we press, we can go there. And now we are going to do a little dirty trick. Right click, set IP. Yeah, so we changed the instruction pointer to be the one in the function that we want to execute. This is a dirty trick that works nicely. So now we are going to step to see the functions that we want. I'm going to enter into this first function, resolve kernel 32 functions, and here we have the load library, the main set, initializing to 0, we don't really care. And then we have the get proc address, it is resolving get proc address with get proc address, yeah, malware tricks, we don't really care. And then after a while, we have this address set here. If we take a look to see what we have now in this keyword, we will see that we have some address, sorry, and if we press O, we will make an offset, and we will see that it is actually the getProcAddress function from the kernel 32 library. So what we have to do the same for all the functions. In this way, we don't lose time in the part of the that malware tools want. What we do is we simply resolve regardless of the decryption method that they are using, so we can later on have a proper IDA database to take a look and analyze it. By the way, you cannot see the registers. Well, I will show you later. So what we can do is we are going to put a breakpoint at the ends, at the variance of the function, and simply let it run by pressing F9. And here we are. Now, if we go to the other keywords that were before, the ones adjacent to the one that we saw at the very beginning, we will see that now we have many others. So what can we do? Either we start doing O, until we get bored. What we can do is, there is a nice script in the IDA's IDZ directory that we are going to use. We are going to select all the keywords pointing to Windows APIs that were already resolved, select them. I'm not sure, let's say, I guess that this is the last one. And then, as I said, we are going to execute that script. That script is always in wherever you have installed IDA, subdirectory IDZ, and the script is called ren imp.idz. I always have it here, recent scripts, renimp.idz. And here we are! It renames the keywords, set the prototype, does many nice stuff. That is what we actually want. Now we can exit from this function, and well, we already have decrypted the kernel 32 functions without actually having to execute this dangerous malware. And then we can do the same sorry, with the advapi 32 functions. We are not even going to go step by step. We will simply go to the last statement, the last instruction, and set a breakpoint and let it run by pressing F9. Okay, here we are. And now, let's go again, do the area where the keywords are, the globals are, and here we are. Okay, some new functions that before were not discovered, interfinals, so, well, we know what to do. Select all of them, and then, where is it? Yeah, run this IDZ script, rename.idz. And here we are. Now we have resolved all the functions. Not surprisingly, it is resolving some crypt functions for probably encrypting or decrypting stuff in the local computer. I haven't researched it too much. And well, we can get out of here. Now, we can continue if we want, like for example, running this code to decrypt test strings. But I believe that pretty much what we wanted to do before is already done. The last remaining thing that we need to do is go into the menu, debugger, and choose take memory snapshot. It will ask if we want to take a memory snapshot of every single segment. You most likely don't want that, unless you want to take a snapshot with every single DLL and every single hex segment in the program. Even when running it inside an emulator, it's quite big. What you usually want, is the loader segments, which is what we want. It will take no time, and then we can stop the emulator. Remember, we never run it, we emulated it, and we will have the functions resolved. And now we can take a look to what we saw before in the DLL main here to determine what it has to do or what it was doing, because before we didn't have any single Windows API resolved. So what it does, it threads some kinds of memory, and then it calls create threads. So this is a thread routine, and then it simply closes the handle, and that's it. Now we call the start come here to the thread routine and do the same for all the strings which are encrypted and are decrypted locally. And then it opens some registry keys in the machine, creates some file, blah 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 blah. We don't really care in this video about that. But, well, we have done what we wanted. We use the Bochs debugger to decrypt Windows-specific malware in Linux, by the way. And, well, we have no problem doing that. And now, after taking a memory snapshot and renaming the global variables that were resolved, we can now we can now research what it does. If we need to, we can do the same for all the strings that are here encrypted and determine which specific registry keys it's reading and stuff. And as I said before, all that we have done is without ever executing it, which is less dangerous than executing it in a virtual machine or even in your own machine, as I have seen it doing many times in some places. And well, that's all for this video. Hope you like it. Bye bye. Have a good.